Roger once again, Mount Fossil University today, once again on the quest for health. And we're going to see what happens inside your body to bacteria. Now, this is from a French Traff. It's called Crawling Neutrophil Chasing Bacterium. Now, that means a neutrophil is a white blood cell. Macrophage, whatever you want to call it. Now, here's what's going to happen. This big guy right here is chasing this little guy because he's not supposed to be in there. You know, they first had a confrontation. He said, "What are you doing here?" The little guy said, "Well, my brother-in-law said it was okay if I come in here." And he said, no, one of these other guys said, "Oh, no. The guy's lying. He got in here because the guy got a cut and there's other guys with him. So you follow up after you take care of this guy." So he says, "Okay, I can handle this." Now, this guy here is working for you. He's in your body, but he's working for you. So you got to feed him right. You got to make sure he's got his transition metals. You got to make sure he's got all of the different minerals and products that he needs to work with. Plus, he's going to have enzymes to take that thing out of your system, break it down into bits and pieces small enough to be brought up to the excretory areas where it can be combined and brought out of your body, just like through your lungs, carbonic acids, through your kidneys, spleen, liver, all that business. It does all these little things to chemistry that has to be removed or has to be brought into your body. So let's watch this poor little bugger. Sometimes I was rooting for him, I gotta be honest with you. Watch this. Look at him. Go get him, buddy. He's trying to kill him. See him? Look, and there's another one over here. He's got his buddies around him. He's going to get them all. He's chasing them. Look at that. Now, if you tell me that's not intelligence, I don't know what to say. Look, he's running. He's going to try to hide between those two. Well, that guy just pushed him out of the way. Nope, you're not getting out of here. Oop. Case closed. Next victim. Okay, Roger, Mount Fossil University, serious situation here. Epstein-Barr virus, which is a disease that has a lot of repercussions. It's an infectious mononucleosis. It's something that some people get and it never goes away, but some people get it, well, most people get it apparently, and never have a problem. So that begs the question, why? Why some don't recover? Now, let's talk about what it says. So these are all kind of things that are just general symptoms. Now, many people infected with EBV, that's Epstein-Barr virus, in childhood. So many people are infected in childhood. EBV infections in children usually do not cause symptoms, or the symptoms are not distinguishable from other mild, brief childhood illnesses. So it's just something your body can deal with, not a big issue. People who get symptoms from EBV infection, usually teenagers or adults, get better in 2 to 4 weeks. However, some people may feel fatigue for several weeks or even months. Some people are reporting that they're not getting better at all. Now, after you get an EBV infection, the virus becomes latent, inactive in your body. In some cases, the virus may reactivate. This does not always cause symptoms, but people with weakened immune systems are more likely to develop symptoms if EBV reactivates. Now, why is your immune system weak? I think it's because you don't have the products in your body or the ability to move them around. So let's talk about that. Okay, let's start with methylation, because my contention is that most of the things that happen in the body are a result of not being able to deliver the correct stuff or pick the correct stuff up and get it out of your body. And that happens because of metals. So, methylation, and why should you care? Well, these are the things that move things around in your body. And after things are used up in your body, which is the enzymes, they have to be destroyed and gotten rid of and methylated and detoxified out of your body. And there's things that do that just automatically. That's the way they work. But if you don't have the metals and the things in your body to do this, it's never going to happen. So what else is there? All right, bacteria versus enzymes versus the chemicals. The bacteria, enzymes, and chemicals. I've shown this many times. That's okay. You're going to have to suffer through it again. Bacteria, living cells that have capabilities of consuming wastes of different types. They're in your body, consuming wastes of different types. They reproduce themselves. They're reproducing. Actually producing enzymes. These are the things that break down all of the molecules in your body so you can digest and eat and get those products around your body through the transition metals. So what else? Better said, bacteria, the factories produce the enzymes. It's the factory to produce the enzymes. You don't even know what enzymes are supposed to be in your body. That's why I need the database. Well, that's why we need the database. But, you know, the database has to be done by somebody. I can't do it. Somebody's got to create a database, and you send in these little test kits and you put the data in the database, and then eventually there'll be norms, and people that are way outside of the norms are going to have some kind of disease that will manifest itself when there's enough data. Just happens that way. No. The enzymes are not alive. They're not alive. The bacteria creates them specifically to do a job, to harvest a chemical. They use them in waste treatment plants. They understand this. Why can't they understand this in your body? So they don't reproduce, and they break up little things, and when they've done their job and there's no more stuff to break up, they just get methylated, which is to get consumed back into your body. But you have to have all the things in your body to do all this. So what's next? All right, carbonic anhydrase. This is how things move around in your body and end up. See, it's a family of enzymes. Family of enzymes. They catalyze interconversions between carbon dioxide and water and disassociate ions, and they form carbonic acids. All right, that's what I'm talking about. Blows out of your lungs. There's 3,500 things now they say in your lungs now. They blow out molecules, different types of molecules. Not just carbon dioxide and oxygen there. No, making enzymes. This is just how they get made and so forth. All right, this is what an enzyme is and what it does, and they accelerate chemical reactions. You have to have these things to make these little bits and pieces break down. The molecules upon which enzymes may act are called substrates. That is the stuff you ate. All right? And the enzyme converts the stuff you ate into different molecules known as products to be delivered around to your body. Those are the products. I mean, how much simpler could it be than this? Absolutely blows my mind. Almost all metabolic processes, that means that life processes in the cell need enzyme catalysts. It boggles my mind. Oh, this is what I'm looking at right here. This is my stuff. This calcarea carbonica I'm going to be looking into. We'll be discussing that later. And it's very interesting, very, very interesting. Anyway, that's another thing. Leading flash, different, not there. All right, now, then it goes into how do you deal with the fatty acids, how you break these things down, and how you get rid of them, and how you use them in your body, and triglycerides, and affects castor oil. No, well, it was just talking about products. All right, castor oil is an 18 carbon chain with a hydroxyl group, which is a atom cracker or a molecule cracker sitting on the 12th carbon, and that's virtually all it is carbon and hydrogen and oxygen, and it seems to be a very effective oil at mimicking enzymes. And they say that. It's one, I guess it's the only one, or it is one of the only ones that is known that can mimic enzymes and create products. So that's my feeling is why it's working in all these different things. Because castor oil works for virtually almost anything. You know, I mean, they've used it. They've known this since Cleopatra's time. She used it for eyes. They use it for hair. They use it for eyelashes, ears, and skin, and joint issues and pains, and rheumatoid arthritis, and all these different issues that have joint pains and so forth, and tendon issues. It's a lubricant. It's a humectant. It takes oxygen. I mean, it doesn't dry out in the air anyway. An event here, effects of castor oil on lipid metabolism in rats. Lipid metabolism, these fatty acids, metabolism is burning them up inside of rats' bodies. They're using them. Okay, so what is it saying? Excuse me. And this goes back to 1999. Now, weanling rats were given diets containing castor oil, so they labeled that CAO, castor oil diet. Coconut oil, CO diet, or high oleric sunflower oil, HO diet, each 10% weight. No growth retardations were observed on the castor oil diets. This castor oil diet group showed significantly lower serum cholesterol and hepatic triglycerols than the HO diet group. Then it says ricinoleic acid was found at extremely low level in perennial adipose tissue. So they're not worried too much about the ricinoleic acids, which could be, I guess they can be toxic if they're not removed from the castor oil, which they do remove them, and I'm sure the removal processes are quite good now. I haven't died. No, I don't think. Now, so castor oil doesn't bother rats. I mean, if it doesn't bother rats, it's probably not going to bother us. No. All right. Now we get into apoptosis, which is cell death. And this is how you prevent yourself from getting cancer and these advanced diseases. So what happens? They have this P53 gene, apparently. They create some kind of pathway to promote cell death. All right, so excuse me. They know this happens, but it works fine in the body. They say, "Ooh, this is a great thing." if it's there, apoptosis works good, but they can't get it to work outside the body. And they say, well, that's not right. It should work and do the same thing outside the body in a culture as it does in the body. Why doesn't it do that? So they realize that there's something in the body that is helping this P53 to do its job of apoptosis, which is to go around and say, you don't look so good. You're going out of here. I'm going to set you up to die. Sorry, what can I do? You don't look good. You got to go. Well, if you don't have a P53 going around doing this, those things get worse and worse and worse and worse, and then they start affecting everybody around. We said, the guy's rotten over there. Somebody get him out of here. They said, well, P53's off the case. He said, why is he off the case? No, that's why we got to understand, why is P53 off the case? Why is he not setting up apoptosis? And I'll tell you something about cannabis, cannabinoids. There's CB1s and CB2s, and they're one of them is the oils that everybody uses for, the cannabis oils. And there's the one that doesn't get you high and the one that gets you high. But there's those two different things cause different reactions in the body, and one of them is apoptosis. It's extremely beneficial plant, extremely beneficial, and not well understood yet, because they really don't understand how castor oil works or these oily substances work. But castor oil is unique among these oils, it says. Anyway, so let's get back to this. Cell death by apoptosis. Cannabinoids do the same thing. There's something in the mechanism of castor oil and enzymes that set these things up to do what they do and to save your life. And you need the metals, and you need the products, and you need the delivery system to make it all work. And sometimes I think they're looking backwards. They're saying, well, P53 is there, So that means, you know, and I'm sorry, let me just back up one step. I was trying to decide why do they come up with all these different terms, this you know, Alzheimer's and RA and muscular dystrophy, and when they're a lot, you know, not necessarily Alzheimer's, but a lot of these things, Parkinson's and all these neuromuscular diseases are, to me, I link them all to some deficiency or some overage of an enzyme or a metal, probably both, and mostly of all is the bacteria that create them right there. So they're just not there. So that's where I go with disease myself. I don't necessarily think that the genes are the things that are causing the diseases to occur, because the genes themselves are sending out and saying, let's make these proteins. I think the proteins are being made as a problem, is created as a problem by some deficiency of the things that I speak of, which are the transition metals of bacteria's enzymes. So the only way to ever tell, the only way, and I'm saying I could be totally wrong, I could be just a moron speaking in the woods here about this, but I don't think so. I think it's right. And the only way to ever know if it's right is to have a database of what is the total spectrum of enzymes, total spectrum of transition metals, total spectrum of bacteria, all of that stuff, total spectrum quantities in a normal average person that is healthy. Now, you're going to have all unhealthy people going in the database, healthy people going in the database. Some are going to have this disease, some are going to have that disease, but in general, you are going to end up with a medium range for every single one of these different chemicals that's in your body. A medium. You're going to have a middle. Nobody says, oh, that won't work. Yes, it will work. Obviously, it'll work. You're going to have a high, you're going to have a low, and in the middle is the middle. Case closed. It's as simple as that. But if you find that everybody is on a very, very low side, 99% of them, that's probably where they all should be, unless they all have some other form of disease. And if they do, they probably have some form of enzyme missing. And if they have some form of enzyme missing, they probably have some form of bacteria missing. All right. End of discussion. I love you. God loves you. Your biology loves you. Love your biology.